let's start. Let's start with our class of the session. Today, I think mm, where are the variables? Okay, today we will start with our particular called Java, your method overriding. Yesterday we did the inheritance. Now we will start with our method overriding and the abstract classes, then packages and interfaces. What is a method? Do you remember that we have gone with the method overloading? Overloading method. Please, anyone can tell me what is a method overloading? Anyone?
The same name, same method name, but different number of parameters.
Yeah, or the different signature and defined
Yeah.
inside the same class.
Yes.
The method overloading must this the method overloading that we have been seen earlier
Mm-hmm.
should always be defined inside inside the same class. Now method overriding. Method overriding this is also a type of polymorphism that we have learned. This method overloading and method overriding are both the type of polymorphism. Means we implement the polymorphism using method overloading and method overriding. Method overriding means when a method in a subclass has the same name, signature, and parameters as a method in super class. So this is method overriding. So what do? We override this method, override a particular method in our subclass, and it has the same name, signature, and parameters. So the difference between overloading and overriding is that the overload has to be done inside the same class, but overriding has to be done in terms of inheritance from the superclass to the subclass. And in overloading, the number of parameters of the signature type is different. In method overriding, the signature parameters, everything has to be same. So let's do a programming. Let's see a program how this is being done, method overriding. And let's, yeah, should we do from here methods overriding, or we can, okay, let's do method overriding, a small program. Let's check a small program. This a, yesterday we were doing int a. Suppose I modify this program. Okay, int, sorry, already I've defined a protected int I. So let's do something called here a int I, a, this dot I equal to I, j equal to j. And let's do it void so only. Now class B, when I'm extending class B, then let's write B int I j int k. Let's do super I comma j. This dot k equal to k. C void this. Let's do C. A this void so this method is being overridden. This is your superclass method. And let's see this. It is this being overridden from the super class. The method has the same name, the superclass. This is the superclass. I'm extending in B. So these methods have the same name, same signature, and your uh, same return type, that is the void. So let's do a program. This is my first program. Let's do this. Did I delete? No, I have this. See, let's see. I have made the method. I have made the method as subject equal to so. Then let's see which particular method is being called here. It is see it is printing me the k this, but still this is not polymorphism. For polymorphism, we need to check, means we are making the b object, so if we are calling the so, it is automatically calling my b object.
Yes.
So let's do something called a. If I had written something here, sub object equal to new b, and then I will do 10, 20, and 30. Let's check this, what it calls. I cannot write k here because I'm making, see what happens here. See, k is 30. It is already calling me 30. So you tell me one thing, when I had given subject K, it is not allowing me, you can see it is not allowing me to define the K, because when I write this type of thing, I I'm trying to refer the object of class A. Let's go to the print, defining this. I am making class A object. First, I am trying to refer, this is a object of, let's write something, that is sub obj. It is first, when I'm writing this way, let's write this. When I'm doing this sub obj, okay, then what happens? It refers the class, it refers to the class A. Remember, this refers to the class A, and this subject now will contain the value null, because I have not used your new. I have not used your new operator. But when I am doing it something called new, again, when I am calling it a new, so this memory reference is updated when I'm calling it like this: A sub object equal to A sub object is equal to this sub obj equal to new. Now I'm doing it as a B. So what it happens, suppose A has I, J, and this so method and this constructor. Leave out the constructor because it is used to initialize the objects, initialize the instance variables. So what it happens when I'm create this, you can only access like this. You can only access here I, J, and your method. So a B here, B can access. See, when I have given a new B has overridden this property, means sorry, it's extended this A, so it has all the properties of A, that is I, J, and then void. So with this object, see, if it is something called this, when I have created this with the new B and sub, I can only access with this with this sub object that has been created to be, only those are being extended. Means we cannot, with this object, if we write this, we cannot just call this functionality called sum, because this particular is not present in A. We cannot call this K, we cannot initialize this K using that, means directly there, because this is not present in A. So when we write anything here like A sub object equal to new B, then only the only the methods which are there in A are being called in the same way. Means only which methods or which variables are present in A, only those can be referred by this particular object when we write in this way. But remember, object dot so it is has printed initializing it using the K here, using the 30, and then I am printing. So this is called my polymorphism. So it's not like that I am making an object of B then I'm calling this. So that means whenever you are creating an object B here, not A, this, if I had created in this way, then automatically it will call this. Now I can call with this object so also, sub object dot sum. This I can easily call because see 45, because I have already initialized again there 10 20, then I have modified it to 7 and 8 here. 7 plus 8 15 plus 30 is equal to 45. But if I had used this as this particular method, see it's giving me a this particular method is not defined in A, it's not defined in A, so we cannot call this particular method using A, means we are referring a object but we are allocating to the B. So is it clear? Any questions you have with this
Uh,
particular? Yeah,
yes. Um, we can pass 30 to K, right?
we can uh, no, we cannot. 30 we are passing because this is the constructors that we are passing through. Okay, this is the constructor, but we cannot
Okay.
explicitly define it again. So we cannot explicitly define it again. It's
Mm-hmm.
not letting me to explicitly define because I'm explicitly defining the I and j again, but it is not allowing me to explicitly define the k. So you want to initialize, you can initialize with the constructor.
Okay. Yeah, got it.
Okay.
Yes.
And any other questions? Tejashwini, Anusha, Sandeep.
No, sir.
So have you understood this particular difference between this and this, these
Yeah.
two?
Yes.
3.64. Yeah.
Okay, okay, yeah. So this is my overriding of functions. So can you tell me? Uh, so remember this overriding of functions. This overriding is my dynamic or runtime polymorphism, because during the runtime when you are creating it anew, when I'm creating it anew, then only, and then I'm giving the means method name. So during the runtime, this whenever you are creating a new, that means dynamically you are allocating any memory. So it's called the dynamic or runtime polymorphism. Whenever you call with this object, you're dynamically allocating the memory to the B references, but it is of A super object, means A objects of class A, object of class A. That means only you can refer the variables of class A or the methods of class A that is being extended in class B. You cannot access this particular sum. Those are exclusively only of B. So during runtime, we are just allocating or dynamically allocating. So it is called the dynamic or runtime polymorphism. This is called your static polymorphism, because you don't need new or something to call this function. Just as the parameters or the signatures are different, just called with a different parameters, then it will be your function overloading. So that will be called the static polymorphism, but here it is called the dynamic or runtime polymorphism. So let's see one more program with that particular called um, polymorphism, and this is a more generic one, a more meaningful one. Let's check this. figure. This is my superclass, maybe double dimension 1, double dimension 2. Now you have the constructor double dimension 1, double dimension 2, and I'm writing a this dot dim1 equal to dim1, this dot dim2 equal to dim2, double area something scissor area for for the figure defined. More use of this when I'm just doing a return just 0 because it wants me to return. This is the class figure. Now let's create another package, and then I'm going to do this. Let's create another package. Polymorphism. The package name is Polymorphism Example. So similar type, just copying this. I'm sending it here. So I moved the figure here. Then I'm creating a class again called rectangle class rectangle extends my figure. I'm writing rectangle double what I written dim 1 comma double dim 2, and I'm doing it here super dim 1 comma dim 2. Now I'm doing a overriding of that particular figure called dim area s. Okay, and then I'm writing a sysout of your particular this, and then inside rectangle, and then passing this return dim1 into dim2. This this is one of the things. And do you remember I asked a question that yesterday that I can extend a class like A extends B or B extends A and C extends A. I asked a question yesterday if it is possible, like, is it possible B extends A and C extends A? Yes, it is possible. So I'm going to do it here now. Like, let's think of a triangle. Okay, it's extending the same class that is called figure, and then I'm writing the again. I need to give the constructor um, double dim A into, sorry, double dim 2. I written correctly. Now double area. Again, I'm overloading this particular call area system inside triangle, return dim1 into dim2. So you see it here. What I did actually, the basic. This is my basic means runtime polymorphism. I have a superclass called figure, and it has a method or a something called area, just the definition of area, nothing else. So I have defined dim1 and dim2 in a dimension 1 and dimension 2 in figure. So just I'm extending this particular functionalities in rectangle and triangle. So a common features, like I mentioned last time, that humans is a common feature. Like here it is a figure. Now it has humans like nose, ears, your mouth, and some of the methods called can walk, can sleep, can sing. These are the methods. These are defined inside humans. Now what it does, the male, it has ears, it has nose, it has mouth. So it is just extending the properties of this particular human. And here the female also can has ears, has nose, and has mouth. So it is just extending the properties of humans. And now the male can sing, the female can also sing. So this is the male can sing in English and the female can sing in Hindi. So this is your full polymorphism, and one of the examples that I am showing here. Okay, so let's call this something called find areas Okay, let's do figure f equal to new. I'm doing it with a rectangle. First, I'm finding it figure doing it a figure only. I'm making it something 10 comma 10. So this constructor, this particular will be 10 10. Now for rectangle, I'm also doing figure rect equal to new rectangle 9 comma 5 with this. Now for figure triangle equal to new triangle, suppose 10 comma 8. Now let's call f dot area or something called double area 1 equal to f dot area double area 2 equal to rect dot area and double area 3 equal to pi area. This out area 1, and I'm doing the sys out of area 2 and 3. Tell me area 1, which particular method this particular area 1 will call? Is it the method this area defined in the figure or rectangle or triangle? Anyone? Hello, you can hear me now, right?
Yes, sir.
Okay,
Yes, sir.
but you cannot view my screen.
Yes.
Okay, I'm asking Kalyani. Kalyani, are you there? Please pass me the presenter role. Okay. Bye. Uh, Hello, you can view my screen, right?
No, sir, we can hear you.
Now we
You
can
Yes,
see.
cannot.
sir. Now
Now
we
we
can see. Now I can see.
Okay, okay. The thing is now, see, this is what I was saying that do you, like humans, do you means I gave an example of the humans. Uh, was I audible at that time?
yeah.
Okay. So tell me, I have written something called figure dimension one double area. The rectangle also I have just overridden this area from that figure, and also triangle I have overridden this area. Tell me what will be called here. First, area 1. Either it will be 0 or the area of the rectangle or area of the triangle. The first one. Anybody?
But the first one will be
Okay.
it's
And
pointing towards the figure, right? Area related to figure.
yeah. Correct. The first one will point always.
Mm-hmm.
I'm making the means I have just made the object of this particular
Yeah.
figure, and I have referred also to the same figure. But you can see here, this rectangle will be the area of the rectangle, and this triangle will be the area of the triangle because I have referred to is rectangle and triangle. So let's check. See, first 0, 9 into 5, 45. Then it's 80. I think triangle area should have been half into base into length. It should have been 2. Half into base into length. Then it should have been my 40. See? So this is the real example of uh, my polymorphism. Now let's see. Suppose if you write something called, you want to prevent this class from being overridden, or you want to prevent this particular class to prevent uh, means to prevent inheritance, means you cannot inherit. So if you do not want this method to be overridden, so what you can do, you just write the keyword final. Do you remember the final keyword doesn't, I had given an example that final keyword doesn't let your instance variable or the variables to be modified later. So when you use a final and initialize the variable during your declaration, like final int I is equal to 10, so if I was doing I plus plus, it was not letting me to particularly modify this. Now let's see what happens. See, I'm getting an error here. It is asking me, it is saying remove final modifier from the figure area. So whenever I'm using a final keyword just before the method, then it doesn't let me to override this particular functionality, because final keyword won't allow this area, means this method, to be modified in later stage. So this is not allowing to override the method. Now if I want, see, now it has let me to override the method. Now I do not want this class to be inherited, so same thing I can do it here. I can write that, see, I have done here, I have made it final class. See, it has again given me an error. It is showing me remove the final modifier. So it is telling me remove the final modifier. So if I write final here, then it is not letting me to inherit the properties of figure. So do you have any questions regarding this final keyword?
No, sir.
Okay. So we are going forward with the called your abstract classes. Do you remember I told you that abstraction is in one of the methods? Then I did something a jar, and I showed you that you are not able to see the main functionalities and everything. So same, the abstract classes is something that you define only once, like this figure or something, but you define the abstract classes. Now what you do, this abstract classes, it contains your abstract methods. So why is in figure this I have shown you that double, like humans, if I written humans, then the common properties are nose, ear, and this you define the common properties inside a class, then you extend it to the other classes. So this is one of the methods, but Java has given me another thing, that is your abstract classes. So you can just define, means you just define the abstract method, means the abstract class with abstract methods, and then you can extend this particular common functionalities in other classes. Like let's do something called abstract class. Remember, whenever you are that you need some certain, okay, methods, like I'm writing the double area, this needs to be overridden by the subclasses, but you can write something called abstract methods. Abstract method means a method which have only the definition, and it does not have the body, it does not have the body, or it does not have your uh, the implementation. So using this figure means I could have written this class as a abstract class. So abstract class is nothing, it's something similar to this figure. So abstract classes means we want to have the common features that are going to be overridden by this particular by the subclasses. So let's check with this. Just give me a moment. Just give me 2 minutes. So yeah, where were we? We were in the abstract classes. Yeah. So at yeah. So in a abstract classes, see, the common features are defined inside the abstract class that I was saying. So let's make this class as an abstract. Okay. Now let's make. I've written something double area. If you remember, then I had to give return 0. But remember, I do not need this body. I do not need this body. So I'm doing it something called abstract method. I do not need this particular body. I just have the definition. So this is an abstract method. Remember, an abstract, when you are defining an abstract method does not have the implementation or the body. This method, this method is just, let me write it here. This method is just defined and will be overridden by subclasses, because this area is a common property. This area is a common property which needs to be overridden in the subclasses. But you can have the concrete methods. Like opposite, when a class have your implementation of the body or anything, then you call it a concrete method. Concrete method means like void. So is your, and I have the definition, I have the implementation here, system dot out dot print ln system dot out dot println abstract class. So this is called my, this particular method which have an implementation always is called the concrete methods. Concrete methods means methods have the implementation or the body. So in an abstract class, you need to define as an abstract class. Now you will have either the concrete methods or the abstract methods. You can have both in this particular called abstraction. So this is my abstract class that I have defined. Now remember, this abstract class, when I'm defining it, we cannot make this particular object. We cannot make the object of this abstract class. So we cannot particularly create, means see here, it has already given me, I cannot write something figure f equal to new figure with an abstract class. You cannot make, or you can refer like this, you could have done it like this way, you could have referred it. But whenever you are using something called new, when you are using a new, that means you are trying to create an object, or you are trying to instantiate this particular class figure. You cannot create an object of this particular class called figure because it is an abstract class. So you cannot create a instance or object of an abstract class. I cannot use this. This also I cannot use. And then you see, I have already extended. I can extend in a similar way, like I can do it. Then I have overridden this double area, and then I have written this particular called double. Also, this particular called double area. Now, this is the finding area. I could have written something called rect. So remember, this is the concrete method that has been defined. This is an abstract class. See, the abstract class, when I've given the symbol is something called A in my Eclipse. So this is my concrete method, and I have called this concrete method. So let's see. Inside this, then this is called this void. So area 1, area 3 is 45 and 40. So is it clear with the abstract classes?
Yes, sir.
Uh, Okay, any questions you have, please forward me so that I'm moving to the next topic, that is this defining of what are these packages means. Okay, now we are going to the packages. We are finished with the abstract classes. Now we are going to the packages. Now packages means the similar type or similar features of the classes can be grouped together inside a package. Like this, I was writing in a single package all the classes. It was something called hazy, but when I have done is a polymorphism example in another package. So these are the similar type of Java classes that I was using for your example, and that I have grouped together inside a package. So you can say a package is definitely the English term. The package means a group. You contain a group of similar classes inside a folder or inside a similar terminology that is called a package. So a package, you just give a name to a particular package. So is a naming convention, is a naming, and also a visibility control system. So visibility control system means private, protected, and this. So I can write here package is both a naming and a visibility control system. This is a called visibility control system. Let's so where I defined the visibility, I don't remember. Yes, here it is. So these are, we have seen private. This can be only accessed within the same class. See, public can be accessed anywhere from the Java universe. Protected, the protected methods can be only accessed, or protected methods of a superclass can only be accessed in particular called protected member uh, in the subclasses. Now default says that we do not explicitly define the modifier, but then it is a default. So whenever declared a default, you can access it by any other class in the same package. So suppose this is my default method. Sorry, where it is gone? Wherever you define something called like this double area or something, if I had not given something called public or anything like this, sorry, cannot be public here. Suppose I had defined here public void. So okay, if I had not defined it anything here, then it would have been my default. So let's check. I'm defining a class, something called class. Sorry, A again. Void so A. I'm writing this particular package. Some example. I'm defining it here. So I have not given. Let's check if I can just access this. Remember, I inside a package. See, these are two different packages. Inside a package, you cannot have the class name should be unique. But as there are two different packages, so the class name is my the class name. I can define similar class name. See, it has A here, it has A here. So inside a package, the class name should be unique, but with the same class name, you can define in other package. So if I'm referring it from my first program, say remember, when I'm referring this A object, then it is taking from me this particular package. Now I want to define this particular A from this particular polymorphism, this particular package. So how would we define it? We can write this way. Object and new A. So there is a difference when I'm writing it A object 1 equal to new A. This is okay. A had some arguments. Just okay. I'm defining it here. A equal to new 10 and 10. So what it is doing, it is calling me. It is calling me like A. This A is being called for this under this package A. When I'm writing a polymorphism, it's like this polymorphism A object equal to this polymorphism this. So this is being referred. So have you understood the difference how I'm calling this to particular functionalities? Because I can directly call because my this first program is inside this package example. So if I'm not defining anything A here, that means it is automatically taking from this package. But when I'm defining the polymorphism dot A equal to this, then it is taking from this package. So let's check. If I do it something called object dot so, did I write so? Okay, now you can check. As I have given this particular functionality A, our default means a default modifier, so it is not letting me to access where it is. Just write it so. So it is not letting me to I'm doing. It is not letting me do so because it is telling me that I need to define. You can see.
It's show A.
No, I've just changed it. I just
Okay.
changed it to so. I just changed it to so. It
Okay.
will not let me because this is this is my default modifier. I haven't used anything, that means it's my default modifier. So default access modifier means a variable or a method declared without any access control modifier is available to any other class in the same package. It would have been, if I would have referred it in the same package, okay, then I could have done. If I have gone to the other package, so as it's a default, I cannot use. So if I had used it, say, as a public, now you check, see, the error has gone. Now it's something called obj object one dot show. Suppose I remove this particular from this class. From this class, I'm removing. Okay, this is the other class. I'm removing this public. Take this. This is I am removing this public. But a this class, this particular class, this refers to this particular class. A this particular class. It has also a show. So as both are having a default modifier. Okay, so with this polymorphism that is inside this class, I cannot access because this is your default constructor. To access this, I need to make it a public. I need to make this public. So you can see. Now let's check. It is polymorphism, and for this it is printing my I and j. So have you understood this, or do you have any questions?
Yes, it's clear.
Okay. And like this is done, and suppose you can import the packages also. Here I was doing my first program. Here it is. Like there are the packages, there are, or Java has already your means you have the classes or you have the packages. The Java has some default packages within it. So someone has written the packages inside it, and they have provided this to us. Like you have something called import. You need to import in this way. Import this package, like you have the util classes, util, and then this. So remember, if you want to do, if you want to something, if I had written something here called another package inside the polymorphism, something called package polymorphism inside something another package, and I had defined it here. If I had defining this, sorry, I cannot class. So let's copy this. If I had written inside this, so I would have checked this. I had writing something wrong. And I have done a biggest mistake here. I will tell you what I have done. My package always should start with a small letter. So this is my biggest mistake. See, if I am writing it here, anything here, I'm doing it in a class, so it is giving me an warning. Suppose, uh, suppose I was making something called, okay. See, when I'm writing this package is discouraged by convention, package names usually start with a lowercase letter. It has giving me a warning. So remember, a package should always be written with a lowercase. So this is a biggest blunder that I have done from their example or polymorphism of this. By definition of Java, it should always be a start with a lowercase letter. So, and this is my Java import java.util.this. So what I particularly do it here. So you can just extend some of these things. Let me import it here. Import java.util.star. You're importing something here and you are extending, or you are extending the date that has been defined inside this Java util and this. So we'll learn more about this particular means the default packages that are given inside. We'll learn more, okay, in the upcoming classes. So let's define, you can import a package, default package, by the using the import keyword. We will see what is this date, what is this particularly these classes that are already defined in the upcoming classes. So we'll tomorrow tomorrow we will start with your interfaces. So do you have any
Excuse
questions
me.
till now? Yeah.
Excuse me, sir.
Yeah.
Uh, what about this other package, polymorphism example inside?
Oh, this was I was showing that if I had created another polymorphism called inside example A, okay, this was I was showing that how to refer this particular package like inside this. So if we would have used inside A, is it like this example A,
Okay,
then you
package
could
inside a
use,
package.
okay,
Okay.
this is this you had written. So we can write numerous type of packages from here. Okay, so you could have
Okay.
written in this way. So hope this is clear with the packages and everything. Now we will be going through the interfaces from tomorrow. Interfaces, remember, this is an 100% abstraction. Now yesterday I had given a question that, do you remember that I had shown that it is already possible. Now A is a superclass, B, this subclass extends A, and C, sorry, here in sorry, B extends A and C. This is possible in Java. Now tell me, can we write something here? A class means we have a class called A and B. Okay, so can C extends or both A and B? Now tomorrow I need to know if this can be done. So there is a class AB. This is the superclass. These two are superclass. These are two independent superclasses. They are not related. Independent superclass. Now you have a C, that is a subclass. Can I extend this particular 2? Means C extends both A and B. Can we do that? Let's go to the next program and we will check. Okay, so we are finishing today. Let's start from tomorrow. Okay.
Okay, sir.
Okay. Yeah.
Okay, sir. Thank you.
Thank you.